Hello, welcome to our presentation. Our project is a stair climbing STAIR-BOT. My name is Mehmet and my friends are Kerem and Taner. Our project is designing and manufacturing a 6-wheel rocker boogie mechanism for climbing stairs with various heights and lengths without tipping over. The robot should generate enough torque to climb and descend from stairs without sliding. It has 6 wheels, which is a rocker boogie mechanism. We also worked on developing a side goal as an addition to our project, which is a self-stabilizing platform while climbing up, which also can carry a load horizontally.
This is the Cad model of our project. All dimensions are same with the dimensions of the real-life robot. The similarity between the Cad model and the real-life robot can be seen in the comparisons photos in the slides. As the vehicle body of the robot, we used 25 mm polypropylene water pipes and welded them together with the pipe elbows. Polypropylene water pipes are easy to use, light and durable as a material. Our design changed over the time, especially on motor holder part. Initially, we tried to use water hose clamp, but it couldn't hold the motor stable. Then we wished to use natural gas pipe clamps. We inserted wooden sticks inside the polypropylene pipes and screwed natural gas clamps, but it wasn't durable either. Finally, we inserted epoxy inside the vehicle body and then screwed the natural gas clamps. In the final design, the motor holders are all stable and durable. Drilling operations of the robot were all made with milling cutter, and they are all exact. In this slide, you can see the technical drawing and the real-life display of the robot. As stated before, the dimensions are all same, and they are very similar to each other.
We use DC motors, Arduino, and motor driver to control our mechanism. There is also a Bluetooth module to control our robot system, which is connected to Arduino. Our side goal is to create a platform that stabilizes itself according to the surface. For this reason, we use the accelerometer to obtain the inclination angle, and with the using Arduino and servo motor, the platform has adjusted the required angle. As I mentioned before, it was our side goal and it may be practiced. Here, you can see our free body diagram. The acting forces and torques can be seen accordingly.
Our battery calculation is here. The max here displays if the robot was on a smooth on a linear surface all the time, and it is actually theoretical. But as for climbing, this value should decrease by around 50% according to our calculations. A, B, and C points on this slide represent wheels, and as you can see, they move up linearly. We have a model on MATLAB which shows how the wheels behave while the robot is climbing.
The DC motors that we used are 30 RPM with a radius of 0.0625 meters. According to these values, we calculate the maximum angular velocity and the maximum velocity of our system. The PWM value between 0 and 256, we used 150. And the representing theoretical velocity is given accordingly. In the right side, you can see our angular velocity and linear velocity theoretically with differentiating RPM and PWM values. Also, we experiment our velocity in horizontal surface as 2.35 meter in 19 seconds, and we calculated our velocity, real velocity, as 0.122 meter per seconds. And the given error rate is 3.06%.
In conclusion, we achieved our main task, which is climbing stairs. Our side task was designing a gimbal-like horizontal platform. We also achieved this task, but stabilization during steady state can be improved using PID controller in the software. Special thanks to Berküler and Poyanias for their helps during the designing and manufacturing process of our project. Thank you for listening us.